big part of advanced functions and modeling is looking at different types of equations and being able to use these equations and manipulate these equations and understand what different parts of these equations really mean. So we're going to be starting this year with linear equations. So hopefully most of this should be review for you, but if it's not, then this should catch you up or let you get there now. So the first thing I want to talk about as far as linear equations is slope. It's a concept you've probably been working with since pre-algebra. Just a couple things I want to say about slope. First of all, a positive slope implies that the line is increasing. Okay, and that means it rises from left to right. Okay, a negative slope implies that the line is decreasing, which means it falls from left to right. Okay, just to make sure everyone's clear on that, I'll just draw a quick example here. If this is our coordinate plane, a positive slope would look something like this. As you move from left to right, it is moving up. Now, a negative slope would look something more like this. As you move from left to right, it's going downward. There are actually two other types of slope you can have, and that's a zero slope and that implies you have a horizontal line. And the last one you can have is no slope, or an undefined slope. And that implies that you have a vertical line. And we'll talk more about horizontal and vertical lines and what their equations look like a little bit later. Okay, so that's the different types of slope you can have: positive, negative, zero, and no slope, and what they imply for the lines. Now next, we're going to talk about how to find the slope of an equation given 2 points. So for example, let's say we wanted to find the slope between -3, -1, and -2, 4. And we're told to find the slope between these 2 points. Like I said, hopefully this is a review for you, but you just use the slope formula: y2 minus y1 over x2 minus x1. Okay, it doesn't really matter which point you call 1 and which point you call 2. The key is whichever one you use first, you've got to use first on the top and the bottom. So I'll just call this x2, y2, x1, y1. So that gives us 4 minus -1 over -2 minus -3. So that gives you a 5 on top over a 1 on the bottom. So our slope is 5. Okay, we'll quickly do one more. Let's say we're going to find the slope between -3, 4 and 2, -2. Again, just make sure whatever point you start with, you need to do on the top and the bottom. So we'll do -2 minus 4 over +2 minus -3. That gives us a -6 on top and a 5 on the bottom. So our slope is -6 over 5. So for the first set of points, we saw a positive slope, which means this line would be increasing. In the second slope, we saw a negative slope, so it would be decreasing. Now that we know how to find a slope given 2 points, we're going to move on to looking at how to find the equation of a line. Okay, now there's several different ways you can approach these, but the point here is that we're being given 1 point and we're being given a slope. Now there are 2 equations we tend to use. One is the slope-intercept form. That's y equals mx plus b. The second is something you may be less familiar with, but it's called the point slope form. And for this particular problem, it's what I would recommend to use. You don't have to use this. If you prefer to use slope intercept, that's fine. But personally, I find it simpler. And the reason is, with slope intercept form, you have to solve for b and then plug it back in and rewrite the equation. With the point slope form, if you're given a point and a slope like we are in this equation, or this problem, excuse me, all we have to do is plug in the points and simplify. We don't have to solve for anything and rewrite, we just plug it in and simplify. So the y1 and the x1 represent your point, and the m represents your slope. So we just do y minus our y value, which is 3, equals m, that's our slope, which is 4, of x minus our x value, which is -1, so minus the -1 becomes +1. So now all we have to do is simplify. Distribute the 4, so you get 4x plus 4, 4 times x, 4 times 1, and then add 3 to both sides. So if you're given a slope and a point, that's how I would recommend you find the equation. Okay, another scenario you might run into is when you're given 2 points. So they may say write the equation of a line passing through 4, -3 and -2, 6. Okay, so this time they gave us the 2 points but not a slope. But if we put together what we've learned so far, we can find this slope. So I'm going to start with finding the slope. I do 6 minus -3 over -2 minus 4. That gives me 9 over -6, which reduces to -3/2. So now I have my slope and I have 2 points. And if we use the point slope form, it does not matter which point you use, it'll come out the same. So just because I'm going to pick this point, again, it doesn't matter, and plug it in. So y minus, the y value here is -3, so minus -3 is like +3. We put -3/2 in for our slope. Then we do x minus our x value, which is 4. So now we distribute the -3/2, so that's -3/2 x. -3/2 times -4 will be +6. Then we subtract 3 from both sides, and we have our answer. So that's the method I would suggest you use if you're trying to solve for an equation given 2 points. So one possibility again is the first example we had of writing the equation of a line where we have 1 point and a slope. There's also a possibility like this where we just are given 2 points and we have to find the slope before we can write the equation. The last thing for today is just to make sure you can look at an equation and figure out the slope and the intercept. Okay, that way, because remember the intercept is a point, but I think I'm getting ahead of myself. So if you notice, our final answers on the last two, we always wrote in slope-intercept form. That's really useful for plugging in our calculator or even graphing it by hand because it gives us the slope and the y-intercept. So let's see, the one back here was that way as well. So those are all in slope-intercept form. So if we're given slope-intercept form, so for example, let's say we have the line y equals 2/3 x plus 2. And we're asked, what is the slope and y-intercept for this equation? Okay, well it's really simple. Remember, it's y equals mx plus b. That's the form we're taking. And m is our slope, and b is our intercept. Our y-intercept is more specific, y-intercept. So that really does give you a point, because a y-intercept is one of the points for your line. So looking at this equation, we can see that the number in front of x is 2/3, so our slope is 2/3, and our number by itself is 2. So it's really important, even if they were to reverse these, even if they wrote this equation as y equals 2 plus 3/2 x, that doesn't change the fact that this is the slope. Slope is going to be whatever number is attached to x. The intercept is going to be whatever number is not attached to x. So our y-intercept is 2. Okay, you could also write that as a point, because remember the y-intercept would be right here on the y-axis at 2, so that would also be the point 0, 2. So if you needed it written as a point, that's one way you could approach it. Write it as 0, 2. But this would be the answer for that. Okay, and if you're looking for practice, just look on pages 188 and 189 of our book.